I guess now that we've talked about prototypes, we can get on to talking about, I guess we can talk about arrays just a little bit. Let's say you had you saw that program that we did the other day, and you want to make a program that can find this, or a function that can find the sum of an array, and you want to pass the array as an argument. So something like this, int sum, and so it'll return the sum of an array. So you want to be able to go integer array 5 equals 1, 2, 3, 4, 5. You want to be able to go cout sum of this array. You want to be able to just output the sum, and you don't want to go through the process. And say you're finding the sum of several arrays, and you don't want to write all the code out again. It's a pretty simple for loop, but you want a function to do it, and that's totally fine. It's possible to pass arrays into your function. The way you do it is you type integer and then the name of what you want it to be called in the function of your, or in the scope of your function. I'll call it sum me, something simple. Let's capitalize that. Sum me, and then you use the 2 square brackets to denote that this is going to be an array. And then what you're also going to need to pass into this function is the length of this array, which is going to mean this number right here, because just passing in that array, you can't figure out how many elements are in that array just from having this variable. So you do have to pass that in, so I'll call that size. And then obviously it's pretty simple. Let's make an int sum equals 0. Size. Do some nice spacing. There we go. Sum me I. Okay, that should work. Let's give it a try. Oh, 2 view. Oh, I forgot to pass in the size. My bad. Okay, there you go. 15. Let's see. That should be right. 3 plus 2 is 5. 1 plus 4 is 5. Okay, just 15. There you go. What you might have noticed is this says function int sum integer pointer int. And you're like, wait, I'm confused. I thought this was an array, not a pointer. And the dealio with that is that when you pass in arrays here, really you're just passing a pointer to the first element in the array. So, um, so if we want, we can prove that. Address of array 0. And then let's just, instead of all this crap, well, we could do that too, but let's go ahead and cout sum me. If you remember, when we went over pointers briefly, we talked about when you cout an array, that'll it'll give you the the address of the first element. Oh gee, sorry about that. The address of the first element in the array. So yeah, you'll see that these are equal. So when you see that this is an integer pointer, note that could also, you might also be passing in an array there. So something to keep in mind. That leads pretty well into what the last thing that I'd like to talk about, which is, let's say you wanted to make a function that you might have encountered this if you've been programming on your own time. For some reason you have let's see, you have no, actually let's do this a little bit more simply. I was going to do something that's kind of hard to explain, so instead we'll just do something pretty simple. Let's say you want to have a function to find or multiply a number by 10. And so, we could have our integer here, and we could do a times equals 10. And obviously, so there's already this ability to do that in one line. So why you would make a function like that, I don't know. Maybe you don't like typing times equals. Maybe you prefer it to be much more clear. But you can do that without having to say a equals times 10a. There's a way to do this without having to do this assignment. And so the way you do that is with pointers or references. Let's do pointers first. So we'll take in an integer pointer, and we'll call that PA. PA, like a, PA. Never mind. So basically you just want to take in, so what we'll do is we'll call this like this, times 10 address of A. So that way, this address of A will get converted to an integer pointer for the purposes of this function, and then we can use that to directly change the value of A. Because basically, we're passing in the address in memory of this variable, and that way we can directly alter the value of that. So all we have to do is use our dereference operator, PA, times equals 10. So this looks really ugly, but there you go, it should work. So let's try it. Cout A before function, A after function. So you notice we're not doing any assignment here, it's all happening within this function. So let's give it a try. Okay, there, A before function is 10, A after function is 100, meaning we multiply it by 10. And so if this was like 3 or something, A before function 3, A after function 30. So that's a way that you can pass in arguments directly without having them copied. If this wasn't a pointer, if we just called this A, and we went like this, and let's call this something else, let's just call this B. So we're trying this times 10, so we might be expecting this to take in A. You're going to multiply it by 10, aren't you? Alright, great. We give it a shot. Nope, doesn't work. A before function is 3, A after function is 3, and that's because when you just have a normal variable like this, instead of bringing the actual memory, the actual address of that memory into this function, it creates a new variable, a temporary variable, and then copies the value of this into the value of this, does whatever's in the function, and doesn't do anything to this integer because it's outside of the scope of the function. So that's something to be aware of when you're making your functions. Another way to accomplish this without using ugly pointers, I think pointers are ugly, like this, what were we doing a second ago, this what is that, 2 asterisks, I don't even, it's really stupid looking. So instead, we can use references to accomplish the same thing, and it'll look a little bit more familiar and logical. So basically, we just declare a reference, RA, and then when we call this times 10, this A is going to be converted to a reference to, sounds kind of weird, but basically, a temporary reference is going to be created that references directly to A. And the great thing about references is that they don't take up any more space. So your program's already using less memory. Even when we had the pointer, it had to make a new pointer, which does take up like 8 bytes, I think. So with references, we're not making any new allocations or any new data, and it's just being directly affected in this function. So if we just do, all we have to do is RA times equals 10. We don't have to use the dereference operator because it's not necessary. There we go. Just as we would have expected with the pointer. But this way we don't have to worry about doing address of A. We can just multiply in, or add, what would you call this? Pass in A, and then this reference is created, which directly references A. So that way this, whatever we do in this function directly affects A. So I think that's all I wanted to talk about in this video. References and prototypes and using pointers and references in your functions. I think that's it. We're going to be moving on to making our own data types, which is super exciting. So get stoked about that. Thanks for watching, you guys. If you didn't like this one, rate it low, but if you did like it, go ahead and rate it high. Leave a comment if you're confused, or send me a message. And subscribe if you want to see new videos as they come out. Thanks, you guys. I'll see you in the next video.